Welcome everyone. This is Rahul Deharkar from Mechanical Engineering Department, School of Technology, PDPU, and today we'll be talking about power transmission devices. So we are aware of electric motors and IC engines, uh, and these IC engines and electric motors are the major source of power. Today's topic of discussion is how to transmit this power via several channels to devices and how to convert that particular power into useful work. Okay, so to give a simple example, rotation motion is provided by the engine. However, the useful work is obtained by the wheels, rotation of the wheels of the particular vehicle. So power transmission from the engine to the wheels is the topic that we would like to discuss today. So now, having a brief thought about what are the key elements in deciding the characteristics for power transmission devices, it's fairly simple to understand what are the key elements that we need to discuss upon. Okay, so we have engine, motor, and we have a device. So with respect to these two things, we have now have to think about what are the key features that is essential for the decision of power transmission. First thing that will come into mind is the connection. There should be connection of both the shafts from the engine to the device. Second is the distance between these two shafts. Third is the power, and four is the direction of the motion. Okay, so it could be sometimes clockwise or it could be reversed depending upon what is the requirement. Also sometimes we might need to be able to stop the device without actually stopping the engine. Okay, so these are the things, parameters that are required. uh, Challenges are obtained with the help of with changes in the orientation of the device and the engine. One such challenge I can show you here. As soon as I just shifted the device at a certain different location, an angle was introduced. So we have to think care of this angle also while transmitting the power. So we have different arrangements in this case. Here are two illustrations. In one of the illustration you can see it is at properly 90 degrees, and another one you can see at some separate angles and looks parallel. Okay, so these are the different challenges that we have to talk about while discussing the power transmission. So moving ahead to the actual one, we have to first talk about drives. Drives are nothing but the moving or the prime machine which is actually running the engines, and there are two types in which we can drive, which is called as individual drive and the group drive. As it suggested, individual drive or the self-contained drive is having machine, has its own electric starter or a motor. Okay, and the motor may drive the shaft through direct coupling, belt, chain, gear, or through some multi-variable speed transmission. So here you can see a single unit of motor or engine is driving a single unit of device, that is a individual drive. In group drive, we have a very powerful motor or a overhead shaft, or basically a prime mover, which is what we can say, which is connected to several devices with the help of a shaft, which overhead shaft, which is called as the main shaft. So in this cases, the main shaft is connected to several devices with the help of the counter shafts. And sometimes we can use fast and loose pulleys also for starting and stopping of the machine spindles. Okay, so this example or this illustration can be very easily visualized with the help of this diagram. In individual drive, we have a single motor which is running a single machine, whereas in group drive we have a single motor which is connected to the main shaft, and then with the help of the counter shaft it is connected to the different several machines. And here itself we can start making a comparison between these two. Let's talk about that in a second. So this is one of the simple example. I request you to think about which particular type of drive will it be. Will this be counted under individual drive, or it will be counted under group drive? You just think about it and you can talk about this with the faculties later on. So having said that, comparison if we do about this too, obviously it is understand that initial investment is higher in individual drive, whereas in group drive it is lower. The speed of the machine can be regulated independently because one single prime mover is rotating the device, whereas in this case we have to use a certain cone pulley arrangement so that the wide range of the spindle speed can be achieved. Okay, it is suitable for small workshop, whereas this is suitable for a medium or a large workshop. In individual drive, failure of a single motor will not affect the performance of the other machines, whereas in group drive, the single motor which is running the system, if it fails, then the entire shop machine workshop floor machines will be stopped. Obviously this is less power is wasted if the machines are underutilized, whereas if the machines are not, it will be more economical when the utilization factor is high. To give this as an example, uh, just look here. If the motor is rotating and only one of this particular engine is running, then we are losing the energy of the given by this particular motor while running or just one engine. We could have usually used a individual drive. So what the sentence is telling here, to have to be more economical, utilization factor must be high. So all the machines should be running continuously. So moving ahead, we now have to talk about the power transmission, and here are the objectives. I hope that made very clear that what we should be objectives. Prime mover to machine, obviously we have to transfer the power from prime mover to machine. Second is long distance power transmission. We also have to transmit power from one shaft to another shaft, modify the speed or force as per our requirement, and control the power. So how it is done? This is done with the help of belt, rope, gears and couplings. Today we are going to discuss belt and ropes. Okay, so let's talk about belt drive. So in belt drive, we have a thin expensive band wrapped tightly over two pulleys which are mounted on shaft. I will show you with the help of animation what it exactly means, but it is fairly easy to understand also. Okay, it is usually used in mills and factories where the distance is not very big. Okay, the power transmission from the driven pulley to the driven pulley by frictional resistance between the belt and the surface of the pulley. So here you have to understand that the power transmission with the belt drive is majorly due to the friction between the belt and the pulleys. Okay, so obviously it gives a chance for slippage, and we will discuss about that in a while, but you have to understand that frictional resistance is the key factor for power transmission here, and there is always some possibility of slipping between the belts and the pulleys when the belt moves over the pulleys. Yes, that is one of the disadvantages of the belt drives. Okay, so let's look at the type of belt that we have over here. So what we have is open belt drive, cross belt, quarter twist, stepped pulley, fast and loose pulley, and compound drive. So even though there are several names, we just have to understand that the discussion that we had about the orientation of the device and the engine will play a major role in determining the type of the belt drive. So when we will be discussing this, we will be looking at what are those things that will be coming to picture. Okay, so open belt drive, this is an open belt drive. As you can see, both the shafts are arranged parallel and their rotation is same. It is quite easy to understand. In this one we have two pulleys over which a belt is suspended on, and this belt is causing the rotation of the rotation of the driven pulley. We have a driver pulley which is connected to a engine or a motor, and we have a driven pulley which is connected to the device, and this is both the shafts are parallel and the rotation is same. So the second one that we have is crossed belt. In this one you can say the same arrangement as the open belt. However, even though they are the same or basically they are parallel, the direction of the rotation is changed, and to achieve that you can see a crossed belt connection is put over here, and this causes larger wear and tear. Okay, so that's it in crossed belt. Later we have a quarter twist one. In this case you can see that the shafts are at a 90-degree angle with one another. So that is one thing in this one, and obviously the rotation of the belt, rotation of the pulleys is in the same direction. Okay, and in this case one of the thing that we have to that we have to remember is that the face of the pulley should be wide enough for not allowing the belt to leave the pulley. So basically here slippage is possible, that the belt could slip off from the pulley. So to avoid that, the face of the pulley should be wide enough. Okay, and we have quarter turn belt with guide pulley. In this case you can see there is a guide pulley which is which is placed between the two pulleys, which helps guide the belt for in this case. Okay, next is the stepped cone pulley drive. And this one you can see that like unlike the previous one, here are several different diameter pulley are arranged stacked with one another, and this helps in changing the speed of the driven shaft without changing the speed of the driver shaft, and this is called as stepped cone pulley drive. Okay, so we have another version of it which is called as fast and loose pulley drive. Here also you can see driving spindle will have a stepped and cone pulley, whereas here also you will see the stepped and cone. One of the key feature here is that we have fixed and loose pulley arrangement here. Okay, which can ensure that when the speed is connected, when this shaft is connected with the help of fixed and loose pulley, then the power is transmitted from here to the output shaft. Whereas if we disengage these two, then even though the driver spindle is on, the power will not be transmitted. So this type of arrangement, fast and loose pulley arrangement, is used when we do not want to stop the driver, whereas we want to stop the device that it is running. So in the group drive I had talked about, so in group drive this kind of arrangement is used where a single motor is driving several machines. So fast and loose pulley drive would be essential there to ensure that whichever machine you want to run can be run. Okay, so moving ahead, we have compound drives. In this one you can see multiple drives are run. So basically several shafts are driven with the central shaft, right? So that is the single thing here. So after going through all this, I request you to have a look at this and give your comments on basically what are the different types, or you just try to classify this arrangement into the several categories that we have done. So here I can see that the shaft is not aligned, or it is not parallel, and also the direction is not same. So which category would it fall in? You can discuss upon that. Let's look at few other examples. This example, so take a look at it and discuss what we have here. As I can see here, we have a single motor, most likely this is the motor, and it has a pulley, and also a separate shaft is connected here. This pulley is rotating another pulley which is connected to the top pulley, and this top pulley is connected to another pulley which is rotating this drill. Whereas we can see this yellow link is connected to the main shaft, and this pink shaft what you can say shaft is also connected. So which type would this kind of category will fall in? You have to discuss on that. Okay, next is this kind of contraption. Here you can see that the driver is the pink shaft, which is the and whereas the blue shaft is the driven. So this kind of arrangement, you can see that the shafts are not always parallel, and also driven shaft is movable. So I again request you to classify this by yourself. Okay, so now we have to talk about the different types of belt. So depending upon the requirements, the belt also varies. We have flat belt, V belt, circular belt, and two-tip belt. Let's look into one by one. Okay, so the choice of the belts will depend upon factors such as speed, reduction ratio, center to center distance, and load capacity. One of the simplest type of belt is flat belts. The main construction is done with the help of leather, rubber, or cotton, and it operates at greater speeds. It can provide opposite direction friction and is available in the form of long straps. This is one of the most widely used type in belt drives. You can seeing it used majorly in mills and at various different operations. Okay, so one of the key disadvantage of this particular type is slippage. The slippage is a major concern over this type of belts. Another is V belts. So as we had talked about the simple belts, the flat belts, this flat belts cannot take what we can say, cannot transmit power. If the quantity of the power is pretty high, it will just break. So in overall, and also the slippage will occur at a higher speeds and higher power. So to overcome that, we have V-belt. So V-belt construction is far more different than the flat belt. It is made up of fabric and vulcanized rubber with a cotton or a nylon core tension elements. So you can see here uh, what you can say, nylon or a cotton cords are embedded into the V shape of this particular belt. The shape is provided in such a V because it would provide higher coefficient of friction when it is on a pulley. And also the pulley would not be a simple pulley. There will be a notch in the pulley required to have V belt uh, used. Okay, so what are the key advantage of the V belt? It can transmit higher torque and less width, and the tension have flat belt, and it is used only for shorter distance. So one of the also, it is expensive compared to the flat belt, but it is used where we require high power or torque transmission from one device to another. Next is timing belt. So timing belt is similar to your flat belt with a small change that they have endless flat belts with regularly spaced teeth formed on one side. Okay, so this teeth that you are looking here helps to have a proper timing given. So this type of belts is usually used in crankshaft, connecting crankshaft and camshaft, where timing is very crucial. So this type of belt is used there. Obviously they are costlier than the flat belt or V belt, and it is used for short distances and to transmit very high power. Okay, this is also made with the help of rubber reinforced, high quality rubber enforced with high tensile fabric cords. Coming to the rope drive, so rope drive basically is similar to the belt drive in functioning, and we just have to talk about what are the different type classification of this. And rope drive can be classified as fiber ropes or wire ropes depending upon its natural and synthetic fabrication process. Fiber ropes is usually made of cottons, and wire ropes are usually used of steel wires. So the in the rope drive, you can see this is one rope. So the construction of this is with the help of strand. Now what is a strand? Number of strands, you can see one strand here like this is one strand. So one multiple strands will generate one wire, and each strand is nothing but twisted wires. Okay, multiple wires will be twisted together to make a strand, and multiple strands will be twisted together to make a rope. So basically ropes may have 3 strands or 9 strands, and each strand may have 7 to 19 wires depending on the application, right? So this was a very short brief upon the power transmission devices, including belt and ropes. For your syllabus, it is only required to have a very brief on this particular topic, which is covered in this particular video. So remaining things will be covered of belt, the gear drive, the coupling will be covered in the later ones. All the animations that was shown today was from this site, from YouTube site. Please use this link to look at various different animations also. Thank you.